Good morning, class. We are looking at trigonometric functions in section 5 or 6.2, graphs of other trigonometric functions. Graph of other trigonometric functions. We want to look at those. So we are going to look at graphs of the tangent, cotangent, cosecant, and secant functions. So we're going to look at y equals a tan omega x, a cotangent omega x, a cosecant omega x, and a secant omega x, and we're going to take it from there. So recall y equals sine x, the domain is when we cut the domain into 0 to 2 pi and we restrict it, then we can use 5 keys. We cut that into 4 equal parts, 4 sub-intervals, 0 to power 2, power 2 to pi, pi to 3 power 2, and 3 power 2 to 2 pi. And now those are the 5 key points: 0, 0, power 2, 1, pi 0, 3 power 2, negative 1, 2 pi 0. And so from here, these sub-intervals, we create those pairs. Now, of course, we continue indefinitely on both sides for the periodic function sine. Same thing for the cosine. We repeat the same thing. We cut this into 4 equal subintervals. Those are the ones. We evaluate them at the end points, and it creates these points with those endpoints: 0, 1, power 2, 0, pi, negative 1, 3 power 2, 0, 2 pi 1. Again, this is a complete cycle. You continue indefinitely on both sides. Okay, and also we learned that sine and cosine are ultimately the same, but there's a phase shift of power 2. That's the meaning of that. And so y equals sine and cosine, both of them have the same period 2 pi, have the same amplitude 1. And if it's a sine omega x or a cosine omega x, they have the same period 2 pi over omega, and the amplitude is a. So that's the synopsis of what we covered. Now we're going to look at other functions. Let's start with tangent. For example, if we were to graph this between negative power 2 and power 3. By the way, normally we don't do that. But in case if we did that, all we have to do, plot some pairs. For example, we picked up those. And so this one, minus pi over 3 gives you negative square root of 3, minus pi over 4 gives you negative 1, minus pi over 6 gives you negative square root of 3 over 2, 0 gives you 0, and on this side you get the same values, positive. Now, for the sake of graph, you don't have to write any of this, just pay attention to the details, class. For the sake of graphing, maybe we go to a decimal representation, and all you have to do in a rectangular coordinate system, plot those pairs, and it looks like that. But I want you to remember, it's not the case, but it almost looks like y equals x cubed. Now, but what if we want the tangent? Well, let's go with, again, easy arcs, negative power 2, negative power 3, and so on. For example, negative power 2, you may remember, is defined. It's undefined because tangent is sine over cosine, and cosine of power 2 or negative power 2 is 0, so it's undefined. Right? It tends either infinity or negative infinity. I will show you the graph. Minus power 3, just like here. Minus power 4, minus power 6, just like here. And the same thing here. And again, power 2 is undefined, and those are the pairs. Now, one complete cycle looks like this. And so what are those? Those are the vertical asymptotes. We have the vertical asymptote at x equals minus pi over 2. We have the vertical asymptote at x equals pi over 2. Now, this is a complete cycle, but you continue indefinitely on both sides, and you get this function. So this is one complete cycle. You can always stick with that and then add to it. Now, Information from tangent. Remember, tangent is sine over cosine. So the domain is all real numbers except whenever the denominator is 0. When is the denominator 0? When cosine is 0, which means odd multiples of power 2, 2n plus 1 times power 2. And by the way, right here from here, it gives rise to vertical asymptotes. X equals that. Range, no restriction, all real numbers. You all remember it was an odd function. You all remember t, the period is pi. And the x-intercept is when this is 0. This is 0 when sine is 0. Sine is 0 at n pi. So that gives you the synopsis of everything you need as far as tangent is concerned, everybody. All right, let's graph this. And again, pay attention to x, and that means you have the same period, t equals pi. And I wrote the synopsis of that for y equals tan x. This is the t. This works out to be the same because x has no coefficient. And so the vertical asymptotes don't change. So first, here's a graph of tangent. We just did that in the previous page. So we want to do a true transformation, everybody. If we multiply by 2, it stretches by a factor of 2. For example, this doesn't change 0, 0, but this becomes power 4, and this number times 2 becomes 2. This remains at minus power 4. We multiply this one by 2. That's the meaning of that. So let's multiply by 2, vertical stretch by a factor of 2. So this part, y equals 2 tan x. Finally, negative 1. Negative 1 means what? Shifted down by 1 unit. When you shift it down by 1 unit, if you look at this one, pi over 4 comma 2, 2 minus 1 becomes 1. 0, 0, 0 remains, 0 minus 1 becomes 0 minus 1. Minus pi over 4 minus 2 becomes minus pi over 4 minus 3. So pay attention to the key points. And of course, as always, it continues indefinitely on both sides. Three tan of 2x. So first notice the period is pi. So this we're going to divide by 2, makes it pi over 2. So if the period changes, so does the VA. All you have to do for the VA, see, you have to put the pi here. Now you have to put pi over 2 here. If I replace this with pi over 2, becomes 2n plus 1 times pi over 4. Okay, please pay attention to this. You put pi over 2 here, and this changes to this one. So just to give you an idea ahead of time. So let's start with the tangent. Again, from the first page. If we multiply this by 3, that means if we stretch it by a factor of 3, looks like that, which means 0, 0 doesn't change, but this becomes power 4, 3, this becomes negative power 4, negative 3. Again, look at just one complete cycle. Never mind the rest, you can add. We are concerned with 1. As long as we can see this, then the rest of them are fine. We are going to now replace the x with 2x, and the result is that there is a horizontal compression by a factor of 1/2. And so in short, if you look at this one, which was x equals negative power 2, now it's negative power 4, and this one, which was pi over 2, is pi over 4. First, look at the vertical asymptotes. Then this doesn't change. But this one, you cut it in half, becomes pi over 8. This one, you cut it in half, becomes minus pi over 8. And again, I want you to be concerned with one complete cycle. Okay, this one, this one, and the rest will follow. Now, one may start with this. In other words, over here, in order to go from here to here, this remains the same, this remains the same. And this is power 8, 1. Power 8, 1. This is minus power 8, negative 1. And then you multiply it by 3. So this can be 1, 2, 3, or 1, 2, 3. Okay, either way is fine as long as you know what you're doing. So y equals 3 tan x. Again, transformation. As long as we can do transformation with one function, we can do it with another one. Basically, this is x over 2. So let's look at the period first. Pi, you're going to divide by 1/2. Again, I want to make sure everybody understand this means half of x, right? So we are going to divide pi by 1/2 becomes 2 pi. So if it's 2 pi, everybody, I'm going to replace this pi with 2 pi. Cancels out the 2, I get pi. Therefore, the VA's vertical asymptote now are 2n plus 1 times pi. Okay, 2n plus 1 times pi. That means, for example, if you choose n to be 0, it's pi. If you choose it to be 1, it's 3 pi. So pi, 3 pi, 5 pi. So odd multiples of pi. The meaning of 2n plus 1 is odd multiples. So you start with tangent. Again, you can multiply it by 3, which means this remains the same. Number 1 becomes 3. 0 times any number is 0. Negative 1 times 3 is negative 3. Take a look. Basically, just like the previous page. Now, we replace the x by x over 2, and that's a horizontal stretch by a factor of 2. What does that mean? Most importantly, this x equals minus pi over 2 changes to x equals minus pi, 2 times that, right? And x equals pi over 2, this is pi over 2, becomes pi. Look at just one. Let me again look at one. Look at one complete cycle. And the changes that you see. So the changes that you see, this 1 and this negative 1 were multiplied by 3. And then now we are going to stretch it. So the x coordinate gets doubled up because of that. So this was pi over 4, 3. Now pi over 4 times 2 becomes pi over 2, 3. 0 doesn't change because 0 times any number. Now minus pi over 4, I'm going to multiply it by 2, becomes minus pi over 2. Minus pi over 2, and the y remains. Now, you can go 1, 2, 3, or you can go 1, 2, 3. If you want to go from here to here first, then pi over 4 changes to pi over 2, but the 1 remains the same. Okay? So you can stretch that, the vertical asymptotes, and stretch pi over 4 to pi negative pi over 2 and negative pi over 4 to negative pi over 2. But the y coordinate remains the same. So it depends how you want to approach that. What about cotangent x? And we do the same thing. Again, we pick up a few easy points, such as pi over 6. Cotangent is square root of 3. Pi over 4 is 1. Pi over 3 is square root of 3 over 3. Pi over 2 is 0. Okay. 2 pi over 3 is negative. Negative square root of 3 over 3. 3 pi over 4 is the same as pi over 4, but negative, so negative 1. And 5 pi over 6, the same as pi over 6, but negative, so minus square root of 3. But what happens if you pick 0, for example? because it's cosine over sine and sine is 0, it blows to either infinity or negative infinity, okay? So remember, for 0, we say undefined. So these are the pairs. If we choose 0, in this case, we would say undefined, okay? So the graph looks like this. Now, of course, almost like minus x cubed moved to the right, of course, okay? Now notice, as x approaches 0, it goes from the right, of course. Goes to infinity, pi goes to negative infinity. This point is pi over 2, at pi over 2 is 0, pi over 4 is 1, and 3 pi over 4 is negative 1. And of course, this is a complete cycle. Now you go indefinitely on both sides. And we're going to write the important aspects of it. Y is cotangent cosine over sine. What is the domain? Domain for any rational function. This is not a rational, but it's a fractional form. You set the denominator equal to 0 and you exclude it. Sine is 0 at n pi, so all real numbers except n pi. So what happens at n pi if this is the case? They become a VA or vertical asymptote. As you recall, it was an odd function with the t being pi. Range, no restrictions or real numbers. X-intercept. X-intercept when y is 0, that means cosine is 0. As you know, cosine is 0 at odd multiples of pi over 2, 2n plus 1 times pi over 2. So that's very straightforward, class. Here's cosecant x. How do you graph cosecant x? Well, cosecant is 1 over sine. So never mind, just graph the sine. Whatever the sine is, sine x, sine 5x, whatever. And then flip it over. Here's sine. Flipping over means that. Flip over the graph. Okay. So this is sine x. The blue one is what we want. And cosecant is 1 over sine. Just like a cotangent, it has the same concept when it comes to the domain, okay? It can't be n pi, and the same thing for the VA, vertical asymptotes. But I want you to notice, sine goes from -1 to 1. The range of sine is -1 to 1. And cosecant can't have those values. So it is all real numbers except from -1 to 1. So here's how we write them. Y is cosecant 1 over sine. Domain, x can't be n pi because sine is 0. And just with the domain goes the VA. With the domain goes the VA. VA is then equal to that. Range, all near real numbers except from -1 to 1. How do you write that? Minus infinity to -1 union 1 to infinity. As you know, it's an odd function because sine is odd, so is cosecant. And t is the same thing as sine, 2 pi. And we don't have any x-intercepts for a basic ones, okay? Unless we shift them up and down. Here's the secant x. By definition is 1 over cosine. So you know how to graph the cosine. Now flip that over. So here's the cosine. So flip it over here, here, and here. Cosine is, secant is 1 over cosine x. Just like tangent that has the denominator cosine, the domain and VA is the same as tangent. So flip over the graph, looking like that. Recall the VA for tangent is the same thing. So y is secant x 1 over cosine x. Domain, cosine x 0, exclude that. Cosine x is 0 at odd multiples of pi over 2, exclude that. And that means this goes with the VA. If you set it equal, those are the vertical asymptotes. Range the same as secant, anywhere between -1 and 1 belongs to cosine, so and it doesn't belong to the secant, so minus infinity to -1. That's a bracket, it includes -1. Union 1 to infinity is even function. Why is that? Because cosine is even, so is secant. And you can see that just from here that even means symmetric with respect to the line, the y-axis, and t is 2 pi, just like cosine, and there is no x-intercept. As an example, if we were to graph this, I want to graph one of those, okay? We don't have to do all of them, they're pretty simple. So we start with the fact that the period is 2 pi. Because the period doesn't change, then the domain doesn't change. The vertical asymptotes remain the same, okay? So this is really a key. And the reason this is the same, because look at x, there is no coefficient. So that really plays a huge deal. So first and foremost, we have to graph sine in order to get to cosecant. So again, this is from previous page. Okay, nothing brand new, previous pages we did there. Okay, cosecant. So same cosecant, which means here's the sine, flip it over. Here's the cosecant. Okay. Now we are going to go with number 2. That means we're going to stretch it by a factor of 2. When you stretch it by a factor of 2, the y coordinates get multiplied by 2. Same thing, pi over 2, 1. Pi over 2 doesn't change, but 1 becomes 2. Okay. Negative pi over 2, -1. -1 becomes -2. This -1 becomes -2. So that's the stretch. Okay. So it moves up in essence. And this would be the graph of, by the way, sine to x. You can even graph sine to x and then flip it over. That's the same concept. So for this part, okay, I mean 2 sine x, my apologies. You can graph 2 sine x and flip it over. And graph 2 sine x and then flip it over. Okay, you have this, you have this. And now we look at the last part is subtracting 1. That means bring this down by 1. When you want to bring this down by 1, this changes to 1, this changes to -3, this changes to -3. Okay, everybody? And that's the graph of the function we are interested in. We discussed the domain, vertical asymptote, period. Now, what happens to the range? Please understand, from -3 to 1 is excluded, right? Okay. So if you look at this one, in essence, okay, we are going to change this to -3 because it was multiplied by 2 and then came down. So from -3 to 1, take a look, -3 to 1. Okay, this is how you get it from the graph. Okay.
Oh, I have a question.
Go ahead.
So what would be the period for this? If
The
we
period
have,
for secant, cosecant is just like sine and cosine. Because it's cosecant of x, you find the t by dividing by the coefficient of x. Since the coefficient of x is 1, the period doesn't change. Okay?
okay, thank you.
My pleasure. So again, just a quick recap. Whenever you want to find the period, remember, for example, when you had omega x for sine or cosine, you would divide by omega, okay? You divide by omega. And in this case, omega is 1. All right, two hallways of 3 feet and 4 feet wide. So this is 3, this is 4 feet wide, meet at a right angle. Show the length of a ladder L is 3 secant theta plus 4 cosecant theta. This angle is theta, everybody. So let's see how we show this length. Okay, let's go over that. So first and foremost, if this is theta, this is theta. Okay, and then this distance, we're going to call this distance x and this distance y. Therefore, and of course, this was 3 feet, this was 4 feet, right? This is 4, this is 4, this is 3, this is 3. And therefore, the length that we want is x plus y. Okay, everybody? So again, a quick recap. This is theta, so is this one, so is this one. This distance, we call it x. This distance, we call it y. This is the same as this one, 3 feet. This is the same as this one, 4 feet. So let's draw each triangle. So if you look at this one, let me use the red color. This one is this one, okay? Cosine of theta is the adjacent over the hypotenuse, 3 over x. And x is 3 over cosine theta. This one is the larger triangle. This side is 4. This is the angle theta. And this is the side y we want. As you know, sine theta is the opposite over the hypotenuse. So sine theta is 4 over y. Therefore, y becomes 4 over sine theta. So L is x plus y. So add the 2. And as you know, when we divide by cosine theta, 3 over cosine theta is 3 secant theta. 4 over sine theta is 4 over 4 cosecant theta. And we are done. Let's look at this question, and as far as the period right here, by the way, we should have all right, class. So now notice the coefficient of x is pi over 2. So right away, just, the t is 2 pi divided pi over 2. So that gives you an idea, the t is 4, just to give you an idea how you calculate the period. So remember, so we have that, okay? So we have y equals secant x or 1 over cosine x. We want to graph minus 3 cosine of power 2 times x. We start with, okay, cosine, and then we go to secant because secant is cosine. So from cosine, we go to secant. I wanted to make sure I mentioned that before, and again, I have it here. The t is 4. So you start with cosine of power 2x. By now, we have seen sine and cosine of power 2x. Please pay attention to just one cycle, and then this is one complete cycle. Okay. And again, what has happened is that we go from 0 to 4, right? That's the period. We want -3 cosine. So let's go with 3. So let's multiply this by 3. That means stretch it by a factor of 3. So for example, here 1 gets multiplied by 3 becomes 3. The same thing here becomes -3. This one becomes 3. And so the graph looks like this. So 0, 3, 4, 3, 2. Okay. And now negate that, meaning flip this over. The same thing, flip it over, right? So you want the secant, flip it over, flip it over. And so we end up with the following domain, range, and VAs. By replacing the values here. The range is very clear. If we have to exclude from here to here, -3 and 3. And the domain X can't be 2n plus 1 times pi over 2. We replace, remember pi is half of 2 pi, everybody. Pi is half of 2 pi. Replace it with half of 4. Everybody, I want to make sure you see how you do that. This is half of 2 pi, yes? Now we are going to replace it with half of 4, which is 2. Okay. That's how we arrive at the answer.